talk adding and subtracting mixed numbers. I have listed here the steps for you to take when adding and subtracting mixed numbers, so let's go over those first. When adding mixed numbers, you are adding integer wholes and parts of those wholes. So to add two mixed numbers, first, you add the integers first. So down here, that would be the 3 and the 4. Add the fraction parts of the mixed number next. So you would then add 4/5 to 2/5, and then regroup if necessary. So I'll walk you through this first example. I have labeled with different colors what I did first. The red marker comes first. I added 3 plus 4, and 3 plus 4 is 7. And then I added 4/5 to 2/5. I already have that common denominator. I'm adding the same units. So 4/5 plus 2/5 is 6/5. But 6/5 is an improper fraction, and we don't like to have improper fractions within mixed numbers, so we like to regroup to make it kind of make sense. Because this is 7, which is 7 wholes, and then 6/5. Well, 6/5 is more than one whole, so we would like to talk about it in terms of how many wholes we have and then how many fractional parts. So if it's 6/5, I then have to, this is my regroup if necessary, I have to think of 6/5 as, well, that's 1 1/5. Remember, 6/5 can also be read as 6 divided by 5. So if I take 1 1/5, so I have 7 and 1 1/5, so then I would just take that 7 and add it to my 1 1/5, and 7 plus 1 1/5 is 8 1/5. So if I had mixed numbers with unlike denominators, I would follow similar steps. I want you to be sure to remember that you need to find a common denominator, so you make sure you're adding like units. You can only add things together that are alike. So first, I can go ahead and confidently add 1 plus 7 is 8. That's wonderful, that's lovely, everything's great. But then I notice that I have 2/15 and 1/6. It's going to be difficult for me to add them if I don't know what to call that fraction, because 15ths and 6ths, they don't add together nicely. So I have to find that common denominator. So I just kind of bring my thoughts down here, and I say, well, I know that the common denominator of 15 and 6 is 30. Now, I have to rewrite them with a denominator of 30. And so I have to say, well, what did I do to 15 to get 30? Well, in my mind, I multiplied by 2. But to keep that value of 2/15, I also multiply the numerator by 2. And what I'm actually doing is multiplying this whole fraction by 1. Because 2 over 2 is 1. Remember, I can multiply a number by 1 and it keeps its value. That's why this works. So 2 times 2 is 4. So I have 4/30. I do the same thing with my 1/6. Well, I multiplied, to get 6 into 30, I need to multiply by 1, but with that factor of 5. And so I'm multiplying by 5/5 this whole fraction, because 6 times 5 is 30, and 1 times 5 is 5. This is still 1/6. It's just in a different form, 5 times 30, or 5/30, excuse me. Now that I have these common denominators, I can add 4/30 to 5/30, and that's going to be 9/30. So my answer, as of right now, is 8 9/30. Well, is that okay? Depending on the story being told, that might be okay. That might be a really good way to answer the question. A lot of times, though, your tests, your quizzes, your teachers, your friends, I don't know, might ask you to simplify that fraction. So I know that 9/30 is not quite simplified all the way. The 8, it's still 8 wholes. Doesn't matter what it's in terms of, really. So that's still 8. And then 9/30, 9 and 30 share a factor of 3. So if I divide both the numerator and the denominator by 3, notice again, I'm not changing the value, I'm just dividing by 1. But I'm taking both of them and dividing by 3 so I can simplify it down. I'm just dividing the whole fraction by 1 though. And 9 divided by 3 is 3. 30 divided by 3 is 10. So 8 and 9/30 is equal to 8 and 3/10. This would be our simplified answer. So let's go over here and try 5 and 1/8 plus 3 and 5/16. I'm going to add 5 plus 3 first. That's going to be 8 again. But I have 1/8 and 5/6. So I'm going to come down here and think about what would a common denominator between 8 and 6 be. I'm going to go through my multiples. I have 8, 16, 24. That's the one. 24ths. That's what I'm working with. If I multiply this 1/8 by 1, but with numerators and denominators of 3, then I know that I keep that value. 3/24 is 1/8, just in a different form. And then 6 to get 24 is a multiplies by 4. So that's going to be 4 over 4. And 5 times 4 is 20. So I still have 1/8. I still have 5/6. It's just in a different form. And then I add those parts together, and I get 23/24. No need to simplify. It's as far as it goes. Moving on to subtraction with mixed numbers. When subtracting mixed numbers, we subtract the fraction portions first, if possible, and then subtract the integers. We look at the fraction parts first because if there needs to be any regrouping, and we'll talk about that in a moment, we want to make sure we get that out of the way first. So first here in my first more simpler example, if I take 7/9 minus 2/9, they share a common denominator. 7 minus 2 is 5, so that's the 5/9. And 10 minus 4 is 6. So my answer is 6 and 5/9. Perfect world, easy problem, not too bad. Sometimes we may need to regroup our mixed numbers so that we can subtract them accurately. So in this case, I have 17 and 1/8 minus 12 and 3/8. If I need to subtract my fraction parts first, taking 3/8 away from 1/8 is going to be a pretty messy process, so I have to regroup. If I look at my 17, I know that this is 17 and 1/8, but I could kind of move the pieces of all of those 17 wholes into eighths, and then take what I need to subtract this 3/8 away. So I'm going to take one of the wholes. Well, one whole, if I'm working with eighths, is 8/8. And so I take that 8/8 and I add it to that 1/8, remembering that I took one away from 17. So this comes up here and becomes 16 and 9/8. I took the 1/8, added the 8/8, and I remembered to take that 1 and turn it into 16. My problem is now rewritten to 16 and 9/8 minus 12 and 3/8. I can take 3/8 from 9/8 to get 6/8, and 12 from 16 to get 4. Now if I needed to simplify, I would make sure to take 6/8 and change it to 3/4, which is its simplest form. 4 and 6/8 is equal to 4 and 3/4, which would be our final solution. You wish you were done, but we're not. Follow the same procedures for adding mixed numbers with unlike denominators when it comes to subtracting numbers with unlike denominators. Okay, so I have 12 and 7/8 minus 5 and 17/24. If you're subtracting, you want to look at those fractional parts first, and immediately you see we have unlike denominators, so we need to work with them as like denominators. If I think about 24 and 8, we just worked with one like that, so I know the common denominator is 24. So because it's 24, the 17/24 remains the same, but I did change 8 to 24 with a factor of 3, so when I multiply, I'm technically multiplying by 1, but it's 3 over 3, so when I multiply here, 7/8 becomes 21/24. I bring down my whole numbers so then I can just go ahead with my process. First, subtract your fractional parts. 21/24 minus 17/24 is 4/24, and then 12 minus 5 is 7. If necessary, then you could simplify And then 4/24, 4 and 24 share a factor of 4, so I'm going to divide by 1 in the form of 4/4 to get 1/6. Don't forget that's 7. So the final answer is 7 1/6 if it needed to be simplified. So here are some examples that we can quickly work through together. If I'm adding 9 2/3 plus 12 2/3, I'm going to add my whole numbers. 9 plus 12 is 21. 2/3 plus 2/3 is 4/3. 21 4/3 looks like a great answer, except for this 4/3 is more than 1 whole. So I'm going to take that 1 whole and put it over with my 21. 4/3 is equal to 1 1/3. So if I take that and add it to my 21, I get 22 1/3. All right. 5 1/8 plus 3 5/6. Is this the example I did before? Let's check. Oh, it is. So we could skip this one. My bad. Coming to C, if I have 12 8/9 minus 8 2/3, then I'm going to subtract my fractional parts first, but I notice they don't share a common denominator. So I want to make them common, and I can tell you that you know that the common denominator between 9 and 3 is 9. I can keep that 8/9 the same, and then that 8 stays the same as well. What did I do to 3 to get 9? I multiplied by 3, so this is going to be times 1 in the form of 3/3, which is 6/9. Now I can subtract 8/9 minus 6/9 is 2/9, and 12 minus 8 is 4. 4 2/9. Lastly is 72 3/5 minus 63 4/5. I have a common denominator, but when I go to subtract my fractional parts, I know that 4/5 is larger than 3/5, so I need to do a little bit of regrouping. I'm going to take 1 whole from 72 and make it 71. 1 whole in this case is 5/5. So I can rewrite this as 71 8/5 minus 63 4/5. Now I can subtract 8/5 minus 4/5. That's not a very pretty 8. 8/5 minus 4/5 is 4/5. And 71 minus 63 is 8. 8 4/5.